So let's talk about mass defect. Mass defect. So we notice that the mass of an atom is always less than the mass of number plus mass of proton. Number of proton plus number of neutron. The mass of an atom is always lesser than the number of proton and the number of neutron combined. It's not supposed to be that way because since it's the number of proton and number of neutron that determines the mass of an atom, it's supposed to be equal, but scientists found out that it's not equal. And the reason for that is because of the energy released. Energy released from the atom. So that's how you calculate the mass defect. So the mass defect will now be the mass of proton, number of proton plus number of neutron minus the actual mass. So the actual in the question, the actual mass will be given. Number of proton will be given, number of neutron will be given. Or they might not give you number of proton neutron, they might just give you this X symbol, then they give you maybe 36 and give you the number of neutron. Like this. So you just find it. So that's how to calculate mass defect. But in the mass of the proton, it will be the formula is not complete. Mass defect will be equal to number of proton times mass of proton plus number of neutron times mass of neutron minus actual mass. So the mass of the proton and neutron will be given in AMU. So now 1.00 something AMU and 1.00 something AMU. So it will be given in the question. The constants are going to be given. So you just impute it and you solve the question. That's how to calculate change in mass. And you get your mass defect, change in mass in AMU. To convert it away from AMU, you multiply times 1.67 times 10 to the minus 27. Minus 27 kilogram. That's to get it in kilogram. You multiply by this to get it in kilogram. Get your answer in AMU, multiply by this and get it in kilogram. Don't worry, I'm going to be solving more questions. I just want you to understand the concept. You multiply it to get it in kilogram. So that's right. So now, there's now a question how to calculate binding energy. It's because of binding energy. That's why the binding energy. That's why the mass of atom is always lesser than the mass of proton and mass of neutron combined. So the binding energy, how to calculate the binding energy? How do we use the Einstein formula? That's E is equal to mc squared. But here we are going to make some tweak. So that we change in m c squared. And we all know that c is velocity of light. That's 3 times 10 to the power 8. So we just square the velocity of light and impute our change in mass, that's mass defect. But this mass defect we are using is not going to be in AMU, it's going to be in kilogram. That means after multiplying our answer with this, we have to multiply our answer with this before we impute it into this formula to get our answer in joule. Understand? So that's how to solve question of mass defect. We're going to be solving some actual questions. In my next video. Now maybe when it's closer to test. I think this week is our test. After shooting this video, I also want to prepare for my own test because I'm not good at it. So what's the next question? So what's the next thing I want to do? So that's how to calculate binding energy. Okay, isotopes. Yeah, isotopes. Isotopes are the same elements that have same proton number but different mass number. And what's making their mass number different is the difference in neutron number. So in the question, they might ask you what the proton does not have, isotope does not have what's in common. And you might not see mass number there. So the answer is neutron number because it's because of their neutron number, because of the difference in their neutron number that is making their mass number different. So they have different mass but same proton number. different mass number, different mass, but same proton number. We have different mass number, different mass, and different neutron numbers. The only thing they have in common is the same proton and the same electron. Understand? This is mine. So how to calculate the calculation of isotope? There's this one I say calculate the atomic number. So the atomic number will be the mass of the isotope times the relative abundance plus mass of the isotope times relative abundance over relative abundance. This one is 100. So there are different ways of solving isotopes.